our function is n of t, which is equal to sine of t over e to the t, plus e, all to the 75th power. So we're trying to find the derivative of that, and we should always look to simplify first, but note that here it's tempting to bring in that 75th power to each term inside the parentheses, but there's not an algebra property that allows you to do that, and it's not true. And so we're really stuck here with this function in its current format. So the big picture here is we have a composite function, and for composite functions we have to use the chain rule. So let's start working on that. The chain rule is the derivative of the outer function evaluated the inner function times the derivative of the inner function. So the derivative of the outer function is the 75th power, taking the derivative of that part. Evaluated the inner function is just 75 times all this junk on the inside, sine of t over e to the t, plus e, we're not modifying that at all, and our new power is 74. So that was the derivative of the outer function evaluated the inner function. Now what we need to do is take the derivative of the inner function. That involves a little bit of work, and so I'm going to go ahead and indicate that I do need to find the derivative of the inside of our function, but I'm not actually doing it in this step. So this is notation saying this. So notice for this first term, we're going to have to use the quotient rule. And then the derivative of the second term, e, it's just e, it's not e to the t, so it's just a constant. Kind of tricky, but it is just a constant. And so that's like the 2.7 whatever, just a constant because it doesn't have that t power. And so the derivative of a constant is 0. Okay, so the quotient rule here, I'm going to actually write that within the answer of this overall problem. So I'm just going to carry this along. 75 parentheses sine of t over e to the t plus e to the 74th power. And now I'm going to actually write out the quotient rule inside some parentheses here. So quotient rule, remember we have our g f prime minus f g prime over g squared, where the top is f and the bottom is g. So our g is e to the t, our f prime is the derivative of sine t, which is cosine t. Then we have minus f, which is just sine of t. And then we have the derivative of g, which is also e to the t. It's a little confusing, but the derivative of e to the t with respect to t is just e to the t. That's all over our g squared, which is e to the t squared. And then plus e, its derivative is 0, so I don't have to include that part. And there's the answer. We should simplify a little bit since we were, told that we didn't have to simplify then, or because, sorry, we weren't told that we don't have to simplify, we should assume that we are going to simplify. That's a good habit. So, alright, what do we got going on here? Notice that we do have an e to the t, that's a common factor. I'm getting lazy here. I'll actually show it here. If you do that, I'll understand on a test or something, but when you look back at the notes, it's a little confusing when I do that for some folks. So I'm going to factor out an e to the t on the top, and notice we have cosine t minus sine t. That remains, and then we have 2 e to the t's in the denominator, so I can cancel a pair out. And then after that, it's pretty much simplified enough. So I'll just write that out, and we're done.
Oh, Girl Scout cookies.
And we're done.